Hello and welcome back to the Answer Me channel. Today we are looking at turning point form. X squared minus 12x plus 36. So, step one. If there's anything in front of the x, divide it by the x and the second coefficient. In this case, our coefficient is 1, so we don't need to do anything. But if that was, say, sum a, then we would go a x squared minus 12 on ax. Now, looking at what we just learned, that would be a times x, which is that, and a times minus 12 on a, which is just minus 12, which would be that. But in this case, our coefficient of x squared is 1, so we don't need to do anything special there. Now, the second step is to divide. So let's just write that up. Step 1, divide terms 1, which has x squared, and term 2, which has by the coefficient of x squared. Now, step 2 then is to divide the coefficient of the x by 2. So we write x minus 12 on 2 squared. So what did I do here? So I removed the square root. I divided negative 12 by 2. I removed the x and I squared it all. So what this will end up being is x minus 6 squared. Okay, but we haven't finished here. So x minus 6 squared, when expanded, gives us x squared minus 12x plus 36. Okay, so you'll notice that what I did here, this is the same as writing x minus 6, and then we go x times x, which is x squared, x minus 6 plus x minus 6x, that's 6x, and then 36. So that is written out fully, x squared minus 6x plus, and then plus 36, which equals x squared minus 12x plus 36. Good. Now, we've been quite lucky with this question because this question equates to a perfect square, because x minus 6 squared gives us this exact term. But there's a way to prove this. So, x minus 6, let's say the last term wasn't 36. So let's just ignore that for a second, and let's just have a look at these first two terms. For x minus 6 squared to be equal x squared minus 12x, which is how we created this, we need to minus this final term squared. So minus 6 squared. Now, why is this? So let's imagine this. So what we just did is we wrote x minus 12, x minus, let's say 6 squared plus 36. So this is obviously going to be much larger than the equation we want, because this plus 36 that we have at the end is being added to the plus 36 we have here. So what we need to do is minus the plus 36 from this square function. So we go x minus 6 squared minus 36 plus 36, which means we get x minus 6 squared plus 0, which is why it works. So step two is to write our first two terms without the x squared and with half the middle term, all squared, minus the square root of this last term. So minus 6 squared plus the last term, plus 36. Step 3, we then solve. In this case, we get minus 6 squared plus 0. We've already done that. So this is our simplified product. Great. So why don't we try this with one more example? So let's say we had x squared plus 7x plus 6. So I won't write all the steps out, but I'll explain it as I go. So first, there's no a in front of the x. So I can just go x plus 7 on 2 squared. So I removed the square, I halved the coefficient of 7x and removed the x. Then I need to minus 7 on 2 squared. Great. And then I need to add 6 plus 6. So when I simplify this, that's x plus 7 on 2 squared minus 49 on 4 plus 6. So if we copy this along to the next page, there we go. So 40 minus 49 on 4 plus 6 is going to give us x plus 7 on 2 squared minus 25 on 4. So we'll look at the end of this video at how we can then take an equation like this and solve for its roots. Another important thing that the turning point formula has, so this is turning point form. Another important thing this tells us is that x is going to, the x value where this equation, so this square root turns, the x value is going to be minus 7 on 2, because as we looked at in the quadratics video, it's whatever makes this equation 0. And y is going to be minus 25 on 4, because the last value is going to be in the turning point. Okay, I hope this has helped. Please subscribe and like if it has. Go to the Answer Me website, which is in the description below, to vote for next week's topic. And stick around if you want to look at more things about factorization. See you then.